All right, thank you, Ray. Actually, it's raining right now, so frankly, I'm in a little less of a hurry than I might have otherwise been. No, I'm also, like Dr. Toit, did not remember to bring a raincoat, so that's another reason I'm not overly anxious to get out in the field. So what we're going to do is we're going to talk a little bit about the soils, resources that you can use. This applies less, of course, to the NRCS folks in the room, because the first thing I'm going to talk about is an NRCS resource that's available to everybody via the web. We're going to talk about web soil survey, and then for a given soil, in the example I've got named in the survey, what are some of the inherent properties that that soil has, what ones make for a good soil, what ones are not so good soil. And then I'm going to spend a brief section on soil health. It's an emerging area. It's kind of a buzz phrase, kind of like what soil quality was in the past. I'll share with you what it means for me and some of the things that I don't think it means what some people think it does. But what properties might be changed to get a healthier soil? So let's start with web soil survey. This is the website that pops up when you just Google web soil survey on the site. And you start by pressing a button, literally a green button on the screen. The first page, the first thing you're going to have to do is enter an address. Now, frankly, I've been using this resource for a long time. And my brother and I, when we were farming together in southern Michigan, we also used soil surveys in that day to scout farms that were coming up for rent. Once you enter the address, you have to indicate a certain area. In this particular case, here is the area that I've delimited using what's called the area of interest indicator. It'll take rectangles. That's great if you're in the Midwest. In Michigan, everything's in rectangles. But when you're in Kentucky, nothing is a rectangle. Everything is irregular, so you're going to use the button on the right over there. But you can then make the first click, scroll, click as you hit a corner, and you can then come up with an irregular map like this one here that I've indicated in red. The first thing that pops up is how much area that is. This is a 12-acre area just south of the old UK Extension office building got blown away in the tornado. And it says, I'm going to use the soil survey area map unit symbols. When you do that, it delineates different areas on this map and assigns these codes. And you can then look and see which codes are associated and how much area within that AOI, area of interest, is assigned to those map units. The nice thing about this is, over here, the symbols are defined. So CRB2, which is this smaller area here and here, are Kreider with a B slope, and it constitutes 22.2% of the area, and it is a bit eroded. Further down, there's a bigger area of Kreider C3, and that's 6 to 12% slope, and it is, even in this grassed over area, severely eroded underneath that grass surface. Something to remember is, when these maps were made, erosion evaluations were made, and then these map units were drawn accordingly. That may not be the case right now because some of the data in these maps is relatively elderly. The larger part of this area, along this drainage way either side of it and merging up into this drainage pilot way, is a lindside. Not eroded, occasionally flooded, but rather small probability. From that, and that's your soil map. Now, let's look at one of these units, and the one I'm going to pick is going to be one of the better map units. It's eroded, but it's not severely eroded. One of the things you want to look at are things like property and qualities that relate to your particular use of this parcel of land. This has got a moderate slope, 2 to 6%. Its depth to restrictive layer is effectively unlimited, so it has a large rooting zone. Drainage class is well drained, which works for you when the season is wet and works a bit against you when the season is dry. It's got a pretty low to moderately high ability to transmit water. Why such a wide range? Depends on the use. If the cattle have treaded it to the point where you've got a pretty significant dense layer, even if it's in the surface millimillimeter, water tends to run off. That's one of the reasons why you want to keep living plants there on that surface as much as possible, because plant roots create porosity, and porosity transmits water rather than letting it run off, transmits it into the soil, and literally plants help collect water that they themselves use later in that rotational cycle of grazing. Let's look at this one. This is more severely eroded. 6 to 12% slope. It's still well drained. It's still a crater. But it's now moved to a medium runoff class, partly because it's got a steeper slope to it. On those steeper lands, the more vulnerable you are to both erosion continuing and to runoff, losing the water that you need on those soils for those plants. But there's no frequency of flooding. Lindside. Now you do have a certain amount of flooding. It's also going to be wetter natured. You might want to, as you can, rotationally be able to move animals out of there when it's wet, because it'll pug. You'll get compaction more quickly on this soil than any other map unit in this area. But it has good available water supply. That means during the drier part of a season, it's going to be holding water that will make those plants grow, and you might be able to rotate onto it a little more often. Another thing you can look at is what we call the suitabilities and limitations for use part. This is, for many of you, one of the more useful parts of web soil survey. You can focus on, in this case, I focused on what I wanted for animal unit months. It provides a rating. This one is a rating of 5.5 animal unit months on this one, and this one has only 5 animal unit months by map unit. Inherent properties that cause limitations in grazing are significant. Soils that are excessively sandy are drouthy. Soils that are excessively clayey can also be drouthy. The best soil for delivering water to a crop is a silt loams, silty clay loams. Most topsoils in Kentucky are made up of those unless they've been eroded. So if you have excessive amounts of sands or excessive amount of clay, you won't deliver as much plant available water. Soils that are stony, sloped, eroded, wet, or shallow to bedrock, or other limiting layer are limited, and the AUMs that come up on suitabilities and limitations is going to be reduced. Inherent properties are difficult to change. You can remove the stones. I know guys that have de-stoned soils in southern Michigan 3 times, 3 different generations, de-stoned them. Drain wet areas. You can do that up to a certain point. You can bring in irrigation. But the bottom line is, a lot of those are pretty expensive for grazing operations. Otherwise, your land management, your animal management, has to optimize the use of the soil resource. Overgrazing is one of the biggest concerns that I have. It's a concern on my own operation, and it's a significant concern that I see in Kentucky. Another common West Kentucky limitation that does extend over to this part of the state, and you see it as a limiting layer, is what we call the fragipan, which is down here starting about 20 inches. It's the start of this discoloration in this soil. Most of the material above it is either silt loam or silty clay loam. It ponds water in the winter. And then in the summer, the roots can only go as far as that pan, and it becomes very dry. It's the same as having a shallow soil, because that fragipan limits the value of that profile to the root system of the crop. What happens is you get a cement that forms in between the beds. That takes away then the ability of those roots to move through those cracks and explore deeper in that soil. Kentucky maps these soils. Again, they're predominantly found in western Kentucky, but they creep into this area of the eastern part of the state. Naturally occurring, it is not formed by tillage or anything like that. It's naturally occurring, and it's the result of new material that was layered over an older soil profile, and it formed something different. The pan stops root growth, water movement is limited, depth of pan 20 to 24 inches, and the fragipan itself is 2 to 4 feet thick, and you can't tile through it. Some people lay tile on top of it to collect the water at this fragipan surface, but fragipan surfaces are irregular and do not follow the topsoil surface. So what you might think it's sloping this way, what you see, but the fragipan may be going that way underneath it because it's an older soil surface. Hence, too wet, late winter, early spring, too dry, in late summer, early fall. Okay, soil health. Soil health, sorry, go ahead.
Is there a way to break that pan up? Subsoiler type work?
Subsoiler will break it, but it tends to re-cement at cracks because it's a chemistry process. But you can get a temporary breakage. Now, here's the rub. In some fragipan soils, right above the pan, there's 4 inches of 4.4 pH soil. So the roots won't even go through that. But that's not universal, therefore, I have to say sometimes when it comes to using a ripper. And the ripper, remember, if your pan's already 20 inches below the surface, you've got a pretty deep ripper to reach down. They make them. They make the diesel it takes to power them. And it has to be dry, which means you're looking at 80 horse per shank. But I don't think the shank density has to be that. You don't have to have, your shank spacing could be further apart. It's been tried with inconsistent success. Other avenues are being explored, but to tell you the truth right now, we have nothing that I recommend strongly. Oh, no, quite all right. Any other questions about that before I leave it? Or about these inherent soil property issues? Soil health revolves around what we call management responsive soil properties. Soil health is about doing something that makes the soil better, but you have to have a fundamental understanding of what you can do to make the soil better and in what class of changes you'll make these management operations. Soil health starts entirely with physical and chemical properties that you can, sometimes cannot manage, because the physical properties define the house, the aggregates, the texture of the soil, define the house in which life occurs. The chemical properties define the utilities, the electricity, the water. In this case, the chemistry is the pH, the nutrients that define how life is sustained. The life that I define here includes plant roots. It is, of course, the microbes, the vertebrates, the invertebrates, but it's also the roots. They live in the soil. These soil chemical and physical properties create the health environment for that life. Soil biology is part of soil life. It is not inherently a property that is easy to manipulate. It is not a lie when they tell you that a teaspoon of soil contains well over 1 billion trillion organisms. A teaspoon. If you think adding a quart of some who-flung stuff is going to make a difference, I have news for you. The bugs that are already there are just going to call it candy and eat them all up. Except there are bugs that you could introduce that do not have to fight for the niche you want them to occupy. Best case, inoculation of legumes. That's a response to biology, to an added small amount of bugs because there was a niche there that was not well occupied. Another one is mycorrhizal fungi. Adding mycorrhizal fungi for certain species of plants in certain environments works like a charm.
Could you just define nodulation in legumes?
I could define it, but it doesn't have to be that way.
Well, tell them what it is.
All right.
We're not speaking our language, in other words.
Legumes, clovers, alfalfa, soybean, will perform much better if they get an assist from some form of bacteria. Some are specific to certain plant species. That's why you buy them in packets by the species. They will cause that plant to be able to fix nitrogen because they form a symbiotic relationship, forming a nodule on the root. That's why when you pull legumes, you don't pull them out of the soil for diagnosis. You take a shovel and you pop them out. That way you can look at those root systems and you can identify nodules. If you want to split one, if it has a pink coloration, that means it's got leg hemoglobin in it, and that means that it is a functioning nodule. Green ones are non-functioning, but they're there. They indicate that there was a bug there at one point, and then white ones, nobody quite knows how to interpret those. But my point is, in the world of microbiology, there are clearly well-known situations where adding microbes has caused a major change in plant productivity, a major assist to root function for the benefit of the crop. Well, most of the stuff that I see on the market today does not meet that criterion, not in the least little bit. That doesn't mean a soil health test shouldn't include a microbiological assay. It might, because, again, a healthier soil supports soil life, might give you a better indication of where you are. But in and of itself, adding more bugs in a jug is not a pathway to success. Because soil biology, like plant growth, is a result of good soil health or bad soil health, as the case may be. The aggregate is the basis of soil structure, and it is the basis of soil physical health. All soils have porosity, but which one of these has structure, functional utility? If you beat the heck out of a soil with a vertical tillage tool, which one of those do you have? Which one of those is better able to resist erosion and a future compressive force, compaction? The problem with structure is you can't assess it by sending a sample to a soil test lab, at least not very easily. There's some soil health test kits where you can send in kind of a lump of soil that you dig out and put in there. In a no-till environment, you tend to preserve structure, and structure tends to preserve porosity that holds water. Now, I admit, a lot of that is up here in this upper end, which means that it's at low tension, which means it's very easily used. This is a graph of the soil water content. Ray showed his grams of water per gram of soil against what's called tension. In this case, let's look at pore diameter. So these big pores hold water weakly, in a weak manner, but it's still there. And this whole portion in here represents water that you as graziers have automatically preserved because you don't do much tillage. But you can lose it if you don't preserve good structure with other animal management practices. What's a little porosity worth? In corn, it's 2 to 4 days between major wilt events. That's a lot. If you talk about soil chemical health, frankly, a classical soil test is the first place to go. You want to do this even though you know you're going to get a different number, a different answer for every field. It is especially important when fertilizer prices are high. And for a lot of people in the grazing world, the automatic refrain I get is fertilizer prices are always too high for us. Well, as Dr. Smith mentioned, in a grazing environment, you are cycling a lot of nutrients. If you manage the animals well, you'll redistribute those nutrients and cause the cycling to be more uniform. But if you let them congregate in shade a lot, if you let them congregate in your water a lot, you know what's going to happen. They're going to congregate nutrients in those places, and they're not out there in the greater body of the pasture where you need them to be. And hay fields are totally different animals. You're extracting nutrients, hauling them to the barn, and where the hay is fed is where the nutrients end up, unless you have a way of moving them back. But you want to target your lime and fertilizer applications to the pastures with greater potential for economic, profitable response. We're going to talk about that later. Soil pH is probably one of the best indicator variables of soil health for pastures and hayfields that I know of. Right now, ag lime is pretty widely available. Other than the cost of actually bringing it to the farm, there haven't been many price changes. And liming these acid pasture soils becomes a high priority because it affects the availability of other nutrients. It's that background utility, that background part of the house. You want to maintain forage legume numbers, you need to have reasonably good pH to encourage their growth and the nitrogen fixation, because those nodules, those bacteria, like a higher pH to do their work. Soil test data comes with values that oftentimes get translated into physical amounts that aren't terribly meaningful in the real world. What we have here is relative yield, meaning we get different responses depending on usually the amount of rainfall, but it could also be sunlight. So we have relative yield on this axis as a function in this figure of soil test phosphorus. Notice this is a physical unit, but it could easily just be an index. Relative yield here versus soil test potassium. The reason it's not a real number is this extractant doesn't get everything that's physically available in the soil. It gets a portion of it. It's true that the higher the value, that does mean your plant availability gets higher. But it doesn't mean you have 50 pounds or 150 pounds. It's not that physical. It's an index of availability. It's also associated with the probability of response. In other words, if you have a very low or low, you have a very high probability of a profitable response to that fertilizer addition. If it's very high, you have a very low probability. This figure is converted into this table right here. Even at the medium test level, it's about 50-50. So that's where you might want to think twice about applying fertilizer. But once it reaches low, I think you're pretty much going to see, unless it gets really dry, you're going to see a response. So good grassland soils have appropriate inherent properties. They have the right texture, profile depth with as few limitations as possible, but they need good health to manage, to give that grass that you need. Now, there's a section in there on interpreting soil test reports that I'm going to talk about in the field school, because I've got a couple of these reports that I want to share with you all about how the soil test report you get can be interpreted. And you have two versions in there because UK is transitioning from what we call the old soil test result report to the new soil test result report. But I thought that might be better when we're out there. Plus, because of the time constraint, I thought we were kind of running short here. All right? Any questions at this point? There'll be a lot of time for questions in the field. Ma'am?
Can you weigh in on calcium? I feel like there's a lot of buzz about like calcium being a fix-all right now.
Calcium is not a fix-all in Kentucky because our soils, generally speaking, are well blessed with calcium that is both plant available and ongoing plant available. Another thing to remember is limestones, which are used to control soil pH, are the major part of those is calcium carbonate. Therefore, as they dissolve to control acidity, the calcium is released and contributes even further to that pool of plant available calcium. Don't get me wrong, there are soils in the world where calcium is a problem. You're not sitting in a state where that's an issue.
Yeah, I'm in Virginia, but...
No, you're not sitting in a state where that's an issue either. No. You do have an area in Virginia goes up into Maryland that are serpentine, and they are very high in magnesium, and they do have to have some calcium added. Because the pH is already a little high, they use gypsum as a source of calcium in certain situations. But it's a rare area.
I guess, so let me clarify. Could you explain why calcium
Calcium is important to plant nutrition, of course, because it affects cell wall integrity. It helps preserve quality in a lot of things like fruits, vegetables, helps preserve their quality. Why it's a buzz? You know, if you got nothing else to sell, you can sell gypsum. I'm serious. If you got nothing else to sell, you can sell liquid calcium.
There are products on the market that are Pro-Cal or liquid calcium, which are not beneficial, and you should not buy those.
Pro-Cal
They
and some
change pH.
Pro-Cal and some of the others are made of calcium chloride. You know what calcium chloride is used for in the biggest tonnage? Road salt. It's the liquid version of, because the other road salt is sodium chloride. If you really want to try that, don't pay their price. Go find out where the County Road Commission buys their liquid road salt. It's a whole lot cheaper there. If you really think you need calcium. Or buy tire ballast. In the old days, nowadays they use calcium acetate because it's not so hard on rims, on the steel rims. But calcium chloride was used as tire ballast. And that market went away, and all of a sudden calcium chloride for plants became a...
All right, one question in the back, and then we got to move on.
Ma'am.
As far as grazing is concerned, is there an optimal time of year to do your soil test, or an optimal time of year to spread your fertilizer for grazing?
Part of the challenge here is it depends on what the problem is. Lime takes some time to react, so if you even suspect you have an acidity problem, take it in the fall, get the lime applied in the fall so that it has time to react, so that next spring growth period sees a higher pH environment and does better because of it. If you don't think you have a pH problem, you can take a sample both in the fall and then late winter, early spring, spread the fertilizer you need as quickly as you can safely get on the field without compaction or rutting, and go ahead and put it on then. I recommend it in the spring simply because it's going to enter the pasture nutrient cycling quicker that way, and then help for a longer period just because it's been present earlier in the situation. With hay, I'm coming to the belief that we need to do more split applications because we're getting early luxury consumption in first cuttings, and then we don't have anything enough left over for second or maybe third cuttings. At least that's what I'm observing on my own farm too.
Is there ever a time when it's too late?
With nitrogen, it can be too late. If you're already over that growth, or well up on that growth hump for fescue, that's too late for nitrogen for that. However, if you have Bermuda grass, I have Bermuda grass on part of my farm, that's about the right time because the Bermuda grass is just starting to take off. And also for the warm season perennials, gamma grass and those, you're going to be a month, month and a half delayed with nitrogen. So nitrogen is one where it can be too late. P and K, they tend to persist longer. So particularly in a pasture environment, they're eventually going to enter the nutrient cycling process.